All right, Algebra 1B students, welcome to part 2 of lesson 7.5. We are in section 7.5, looking at page 449 today. So turn with me there, please. And just want to remind you of what we looked at in our last video, dealing with cubed roots or radicals in general and rational exponents. So just as a reminder, the cubed root or the third root of 27, we decided that was the same thing as 27 to the 1/3. These are equal, right? Same thing with the fifth root of 32 and 32 to the 1/5 power. These are equal, okay? And we go down, look at a couple more here. The cube root of 64 is equal to 64 to the 1/3, and the square root of 36 is equal to 36 to the 1/2 power. So what I want you to notice or remind you of is that this index also shows up here in the bottom of our fraction. In our exponent, right? In the denominator of our fraction. So that is going to be very, very important today. So please make note of this, that the index and the denominator of our fraction are the same number. Okay? Now, the question we're going to ask in this video is this. What about the cube root of, the cube root of 8 squared? Say 8 squared. The cube root of 8 squared. Right? Now we know that the cube root of something is just that number to the 1/3 power. Just a reminder that the 3 that's here is also showing up over here. Right? So the cube root or third root of 8 to the 2nd power, that's the same as 8 to the 2nd power raised to the 1/3 power. Right? But now we know if we take a power and raise it to another power, what are we really doing with those exponents there? We should be multiplying them. So 2 times the 1/3 power, if we're raising to the 2nd and then to the 1/3, is to the 2/3 power. So now we are down here. So the third root of 8 to the 2nd power became 8 to the 2nd 8 to the 2/3 power, excuse me. So again, our index over here is still showing up in the denominator right there. And now the power that we see inside the root is the numerator. This one here has now shown up over here. All right? Let's look at one more very much related example. Now I'm doing the third root of 8 in parentheses, and then taking all of that to the 2nd power. So now in the parentheses, I know that the third root of 8 is 8 to the 1/3 power. I'm still raising to the 2nd. But again, when I raise 8 to the 1/3 power to the 2nd power, what do I do with those exponents? Again, I multiply them, which means I should still be at 8 to the 2/3. Okay? Just want to point out again that the index of your radical is still the denominator of your fraction, and now the power that you are raising it to is the numerator of that fraction right there. Okay? Please take note of those. If you have questions about what I just did, either one of these examples, please make a note to ask me that in class tomorrow. We're going to go on and look at our general rule that we can add to our notes, and then we'll look at a couple practice problems. All right, so here we are. Here is our rule. And I will write it again for you because I know it's very hard to read up here. You can find this in your book on page 449. Page 449, right there towards the top, the key concept box. Right? What this says is that a to the m over n power. That's any fraction you want. 1/2, 2/3, 17 over 25, whatever you want. That is the same as the nth root, or n as the index with the root symbol, and then it's still our big A to the m power. All right? It also says that is the same as, in parentheses, our nth root, n as the index, root symbol, big A, close parentheses, raise all over to the n power. All three of those things are exactly the same. Okay? Please add that to your notes. And then we will go on and look at this first example problem right down here. What is 12 times a to the 2/3 power in radical form? So let's look together at that problem. And here's what I need to notice first. I need to look at this expression that they have given me right here and decide how many pieces do I have there and how many of them have an exponent on them. Okay? Now, we don't see any parentheses, so keep that in mind as we do this. I see two pieces. I see a 12, and then I see an A, and the only one that has an exponent attached is the A to the 2/3 power. All right? So because the 12 doesn't have an exponent at all, we're not going to do anything with it. We're just going to leave it alone, leave it the way it is. Right? But we are going to address this A to the 2/3 power and try to write that in some equivalent way that deals with radicals. Okay? Something like this, some sort of radical. Right? Now, hopefully from the last slide and all of my circling things, you've realized that the index of my radical should be the denominator of my fraction. Okay, so I know anytime I see a to the something over 3, I'm going to be taking the third root of something. All right? And really I'm taking the third root of still a, and the numerator of my fraction over here is still an exponent on my a. So a to the 2/3 really is the same as the third root of a to the 2nd power. Right? Now I go back to my expression over here, and I keep the 12 the same, but I rewrite the a to the 2/3 power. So I'm going to write 12 times the third root of a to the 2nd. And I'm done. And that's it. There is my answer right there. 12 times the third root of a squared. I just rewrote the a part because that's what had the exponent on it. All right? I want you to look at these two problems, please. The got it number 2 right there in the middle of page 449. Take a look at number 2, letter A and B, writing each expression in radical form. Please notice in letter B, the 5 does not have a power attached to it. All right, so pause the video, take a look at those two problems, then come back and we'll go on to our other type of example problem. Okay, let's go on then and go the other direction. Okay, we just worked on writing things that had rational exponents in radicals. Now we're going to go backwards and we're going to write things that are already radicals in exponent form or in exponential form. Exponential means with exponents. That means with exponents. So they're giving us this expression, the 5th root of b to the 3rd power. Okay? Now again, going back to our last slide and all of my circling things, hopefully we know by now that the index of my radical eventually is going to be the denominator of a fraction. That's going to end up in my exponent. Right? So I know that already. It's going to be something over 5 because I see the 5th root there. Okay? I know that I'm still going to be dealing with this giant b. I'm going to be doing something to the b. And the only piece that's missing now is the power that I'm taking the b to in here is just going to plop down here and be the numerator of that fraction. So the 5th root of b to the 3rd power, well, that's b to the 3. Now I just put it over 5. Okay? Over 5 because it's the 5th root right here. Now let's look at the next example where we have a little bit more to deal with here. Okay? Here they want to know what is the 3rd root of 27d to the 5th in exponential form, meaning with exponents. And then they want us to simplify whatever we can, okay? Now, here is the way that we need to do this one. This one, I'm going to take this third root and just remind you that the third root of something equals that thing to the 1/3 power. Right? So let's just say I put x. The third root of x is x to the 1/3. So I'm going to use that now to rewrite this expression with a 1/3 power instead of a cube root or a third root. Okay? So I'm going to take this guy and I'm going to transplant him right over there. And he is going to become 27d to the 5th to the 1/3. Okay, all I've done is taken what was under my third root, this whole 27d to the 5th piece, and I'm now raising it to the 1/3 because I know that's the same as a cube root. So now I have two different pieces here that are both being raised to the 1/3, right? That's what these parentheses mean. I'm taking my 27 and my d to the 5th and raising them to the 1/3 power. Okay? So that means I need to take this 1/3 power and I need to attach it to the 27 and I need to attach it to the d to the 5th. Right? So I'm going to do both of those. This is the same as or equal to 27 to the 1/3 power times d to the 5th to the 1/3 power. Okay? The 27 to the 1/3 power, hopefully we can figure that out, or maybe we know it by now, that 27 to the 1/3 is 3. Right? That's the cube root of 27. And then this d to the 5th to the 1/3 power, when we raise a power to a power, what do we do with the exponents? We multiply them. So this is 3 times d to the 5/1 times 1/3 is going to be 5/3. Okay, so that is our final simplified finished answer. All right? And the simplified piece here that they gave us in our directions was just talking about the 27 to the 1/3, all of that junk, that we turned into a 3. That's what they mean by simplify. Okay? So your final answer there should be 3d to the 5/3 power, 5/3 power. All right? Again, if you have a question about that, go back, re-watch, re-listen to what I did. If you still don't get it, make a note, please, to ask me in class tomorrow. Once you think you've got this down, take a look now at the top of page 450. It's now page 450. And I want you to take a look at A, B, and C. They're at the very top for God at number 3. All right, so I want you to write each one of those things in exponential form, meaning with exponents instead of with radicals. All right, so take a look at those. These guys right here. When you are finished, you are all ready for your practice problem set. And that is all I have for you tonight. Have a wonderful night.